Evening, I'm Spot on Weather meteorologist Matthew Euler. Welcome to my latest video. Now, what I wanted to do is, starting with this month, September 2023, what I really want to do is focus in on the winter outlooks from the long-range models. And these come out generally between the 1st and the 10th of each month. The IRI, the International Research Institute, that model comes out on the 15th of the month. But majority of the long-range models for seasonal forecasts come out generally in the first 10 days of each month. So what I wanted to do is start with September 2023. We're going to take a look at the various long-range models for the upcoming winter season. When I define winter season, I'm talking about the months of December, January, and February. And what we're going to do is each month, we'll start with September. I'll do a video in October, early October. I'll do a video in early November. We're going to take a look at the next few months for the winter outlooks from these models. And then what I'd like to do at the end of the winter is go back and I'll do a special video comparing which one of these long-range models perform the best. So let's go ahead and get started with tonight's video. It won't be very long, but it will be very meaningful to see what the latest long-range models are projecting for the upcoming 2023-24 winter season. Here is the overview of this presentation. I'm going to start with the CanSIPS winter forecast. Then we'll work our way towards the ECMWF C5 winter forecast, the NMME winter forecast, and then the C3S winter forecast, which just came out yesterday. So just a little bit of tidbits before I go into the actual graphics for the winter forecast. What exactly is CanSIPS? Well, CanSIPS stands for the Canadian Seasonal to Interannual Prediction System. It's a multi-model ensemble, so multiple models are run as part of its suite using primarily two of those climate models are the models developed by the Canadian Centre for Climate Modelling and Analysis, the CCCMA, and then the Canadian Meteorological Centre, the CMC. What CanSIPS provides are probabilistic predictions of atmospheric elements, generally from the beginning of the month out 12 months into the future. And the atmospheric elements include temperature, precipitation, wind speed and direction, as well as many others that I'm not mentioning. Overall, the coverage is globally. It's a global geographic coverage for this model output, the CanSIPS. So let's start now in each of the slides, which I'm going to mention how these slides are orientated. The far left graphic is going to be for the month of December in each slide. The middle graphic will be January, and this far right graphic will be February. So basically, meteorological winter, December, January, and February for each of the slides. I'm going to look at a variety of parameters that I like to look at as far as what we can expect for the upcoming winter season. So let's start first with the CanSIPS 500 millibar height anomaly forecast. Anytime you see the orange colors or these lighter yellow colors, that's indicative of above normal heights forecasted. And whenever you see the blue shading, that is indicating a forecast of below normal heights, going back to the 1991 to 2020 hindcast climatology. All right, so let's take a look over here and start off here on the left with the 500 millibar height anomaly forecast from the CanSIPS model, showing some well above normal upper level heights in the mid-levels of the atmosphere at 500 millibars, generally across the eastern portions of Canada for the month of December. The rest of the United States, not really much in the way of above or below normal height anomalies. Looks more like zonal west to east type conditions. The ridging is going to be over the top here though, across Canada, and that is typically associated with a negative phase of the North Atlantic Oscillation. Over here in the middle, let's take a look at the January forecast. Now we have below normal heights. Whenever you get these below normal heights, this blue shading is typically associated with unsettled weather conditions and cooler than normal conditions whenever you see the blue. Whenever you see the orange coloring, that's indicative of upper level height anomalies that are higher than normal, also associated with upper level ridging. And we still see in the month of January, the CanSIPS forecast is for that same area in eastern and northeastern Canada to be dominated by above normal heights. We see now more of lower than normal heights off the coast of California in January. The rest of the United States pretty much near normal heights or average heights based on climatology for January. And then over here on the right, here's the forecast, the 500 millibar height anomaly forecast. Now we have well below normal heights across the northern Pacific. This is very well could be associated with a stronger Aleutian low pressure system in the vicinity of the Aleutian Islands here in Alaska. And now we see the west coast near normal heights, but then we see this bullseye, the southeastern U.S. up to the mid-Atlantic and off the east coast below normal heights. So we have a dip in the jet stream here along the eastern seaboard, according to the CanSIPS model for the month of February, and that would be indicative of stormy conditions and colder than normal temperatures in general. So again, what's the main theme here for the CanSIPS 500 millibar height anomaly forecast is higher than normal heights across the North Atlantic, extending westward into northeastern Canada on all 3 months. Again, this would be associated with a negative phase of the North Atlantic Oscillation, or NAO. Let's take a look at the CanSIPS temperature anomaly forecast now at 2 meters, 2-meter temperature anomaly forecast in degrees Celsius. Over here on the left, CanSIPS is showing the orangish coloring here. That's indicative of above normal temperatures. Whenever you see the blue shading, that's indicative of below normal temperatures. So CanSIPS in December is forecasting for above normal temperatures in the same area where they were forecasting higher or above normal heights across eastern Canada towards Hudson Bay. And then generally slightly above normal temperatures into the mid-Atlantic and up to New England. General normal temperatures to the west coast, right along the southern U.S., right over to Florida. For the month of January, the CanSIPS is forecasting above normal temperatures across eastern Canada, that same location, all the way down to the Midwest. And now we're starting to see some below normal temperatures indicated by this blue shading across the southeastern U.S., extending up towards the Carolinas by January. And over here on the right is the CanSIPS temperature anomaly forecast of 2 meters for February of 2024, showing now a very distinct signature of below normal temperatures across portions of Georgia, working our way northeast into the Carolinas and Virginia and West Virginia, extending a little further north up towards Massachusetts and Rhode Island, Pennsylvania, New Jersey. And we see above normal temperatures again remaining pretty much where the other 2 months of the winter we're forecasting them to occur. So not much change. If anything, as far as change goes for the month of February for the CanSIPS temperature anomaly forecast, it would be this above normal temperature area across the Pacific Northwest by February. Looking at the CanSIPS precipitation anomaly forecast for December, January, and February, green coloring on these precipitation anomaly charts indicates above normal precip, yellow below normal precip. So for the month of December 2023, we see quite a wide stretch of above normal precipitation forecast for December from the Gulf Coast all the way up to the Mid-Atlantic and to New England. Very, very wet. We see below normal precip across Southern California as well as parts of Texas. And then we also see slightly above normal precipitation across parts of the Pacific Northwest into Washington, Oregon in December. Now, as we move towards January 2024, the precipitation anomaly forecast, according to CanSIPS, is showing that same area. It's extended back a little bit further to the west towards eastern and southern Texas, all the way up to right along the Gulf Coast into Florida, up to the Mid-Atlantic. Also extending northward up into New Jersey and parts of New England, coastal New England, in January 2024. Drier than normal conditions expected in January 2024 across Iowa, Nebraska, and the central U.S., and look at this above normal area all the way up and down the U.S. West Coast from Washington State, from Seattle, working our way down towards LA for the month of January. Over here, February 2024. Wow, this is not... Okay, it's listed as... That's interesting. Okay, no, it's right. Okay. So in general, what we see for February 2024 from CanSIPS is, again, above normal precip, the same theme from the northeastern Gulf of Mexico, including you in Florida, as well as Alabama, Georgia, into the Carolinas, up to Virginia. And we see a much more widespread, drier than normal conditions across the Ohio Valley and the Midwest by February 2024 by late winter. Now let's transition over to the ECMWF CS5 model. This, just some general facts about the model. It produces seasonal forecasts, and it became operational in November 2017. There are some research articles that are written on this particular model. I personally like this model. I think it's a very accurate model. I've been following it closely and just to kind of see how it's picking up on some of the patterns, and I think it's a pretty good model. It is an ocean model with atmospheric resolution and provides land surface initialization. Additionally, the ECMWF sees 5 is a grid point, horizontal resolution, grid point model with horizontal resolution, it's 36 kilometers, and 91 layers in the vertical to capture some of those vertical processes. And another good thing about this particular model, it includes ocean, ice, and atmospheric coupling. Whenever you couple the atmosphere with the underlying surface, whether it be ice or ocean, that tends to really better capture what's going on in that coupling effect. When I say coupling, the connection between the underlying surface and the overlying air. So let's take a look at the ECMWF seas 5 500 millibar height anomaly forecast. This was issued on the 1st of September 2023. Starting over here on the left, now we're showing 500 millibar height anomalies generally in this slide here. Notice this bright orange coloring here, reddish coloring. The brighter this color is, the higher the forecasted heights are going to be. And so you see some anomalously high heights across New England, all the way over northwestward into eastern Canada. You see one area of blue here indicating lower than normal heights forecasted for Texas and New Mexico. But in general, the mid-Atlantic, a little bit lighter color orange here, that is going to indicate slightly above normal heights for the month of December, according to this model. We move over here now to January in the middle and then February 2024 forecast on the right, and wow, what a difference here. So we notice as higher than normal heights continue into Canada. It looks like by January, this model is forecasting those higher than normal heights to shift further to the west, along the west coast of Canada. Okay, so this signature here in December is, to me, again, more indicative of a negative NAO phase. And then this over here in the middle of January 2024, this is indicative, with those higher than normal heights shifting west, more of a positive PNA pattern. Okay. In either case, you usually get some colder temperatures beneath these higher than normal heights in the higher latitudes. Okay. And so we're seeing that in January 2024, a bullish looking forecast. By the way, this particular model, I also need to mention that it has 51 ensembles. So 51 ensemble members to this model. Look at the green coloring indicating anomalously below normal heights. Now that's going to be associated with storminess in general. I had a question, hey, what does this mean exactly? If you're a non-meteorologist, whenever you see this green and blue shading indicative of lower than normal heights at the 500 millibar level, that's indicative of stormy conditions. And so this is really a storm bullseye area here across the Carolinas and Virginia for the month of January, according to the ECMWF seas 5 500 millibar height anomaly forecast. And then you see over here to the far right, this is the February 2024 forecast from the ECMWF seas 5. Look at the connection of blues now from Southern California along the Interstate 10 corridor, working our way all the way down to Texas and southeastern U.S., the Gulf Coast, Florida. But the bullseye again is up here in the mid-Atlantic and just offshore the mid-Atlantic. So this here, to me, if I'm looking at these graphics for January and February, according to this model forecast, this would be indicative of a lot of stormy conditions across the mid-Atlantic. And also, by February, I'm anticipating a storm track to basically move from Southern California down along the Gulf Coast and then potentially offshore as some sort of nor'easter, generally offshore of the mid-Atlantic. So just in general, you kind of see what my summaries are here at the bottom. I kind of already hinted at the fact that this green shading, this anomalously lower than normal height forecast, generally portends more storm development. And that's exactly what we're seeing in the months of January and February. Now let's take a look at the temperature anomaly forecast. Okay, now this is the 2-meter temperature anomaly forecast showing for the month of December. This isn't anything to write home about, is it? But look at the above normal temperatures again. This was in a similar area to what we already looked at with the CanSIPS model. Same general idea here. Well above normal temperatures across eastern and southeastern Canada up to Hudson Bay. Same thing here in January. All right, and then by February, some of that warmer than normal temperature shift a little further toward the North Atlantic and then also back towards the western parts of Canada. But look at what's happening across the United States. December, like I said, in the mid-Atlantic, nothing really to write home about. Slightly above normal temperatures. Now, when I look at this lighter orange shading for the Virginia and down in North Carolina, for example, that's indicative of about a 1 degree Celsius above normal situation for December. Okay. Blue shading, below normal temperatures are forecasted in Texas up to the front range of the Rockies. Okay. And then over here, and when we look over here, the middle graphic for January 2024, a temperature anomaly forecast, look at the blue now, extending from East Texas right along the Gulf Coast, the southeastern U.S. up to the mid-Atlantic. This is indicative of below normal temperatures. Not drastically below normal, but below normal nonetheless. And then over here on the far right for February 2024, look at the same area, southeastern U.S. to mid-Atlantic, below normal temperatures, you in Florida as well. So right now, this is an intriguing forecast. It's a fairly accurate model. It's very similar in its December temperature outlook over here on the left as compared to the CanSIPS model, which we looked at, featuring slightly above average temps for the mid-Atlantic in December, and then that gives way to colder than normal temps in January and February. Now let's look at the precipitation anomaly forecast. December here on the left, the green coloring again indicating above normal precip, all the way from the Gulf Coast all the way up to the Mid-Atlantic and New England in December. It looks like a wet start to the winter season across these areas. By the time we get over here in the middle, the forecast for January 2024, we also have wet conditions generally in the same areas from Florida up to Georgia, to the Carolinas, Virginia, and up to New England. And then over here on the far right, we see now a more distinct area of drier than normal, this brown shading, drier than normal conditions in February 2024 for the Ohio Valley. Kentucky, Tennessee, West Virginia, Ohio, right in that area. And the above normal precip continues from Florida right up along the mid-Atlantic coast. And also notice during an El Nino winter, this is quite common, we see drier than normal conditions across the Pacific Northwest by February of 2024. The storm track is much further south with El Nino. It's not up here with like La Nina up towards the Pacific Northwest. The storm track and the jet stream are further south. That's why you're seeing this. We get a more active subtropical jet stream during El Nino winters and the coastal storm development right here on the East Coast. Now let's take a look at the North American Multi-Model Ensemble, the NMME forecast for this upcoming winter season. Seasonal, I'm just going to kind of break it down again. NMME is a seasonal forecasting system that consists of multiple coupled models from North American modeling centers, and it provides 12-month forecast for 13 key variables. I won't list those all right here, but let's go into the forecast. Now, the NMME temp anomaly forecast for December, over here on the left, generally showing slightly above normal temps for a large section of the United States, this light yellow coloring, okay? A little bit more above normal across the parts of the upper Midwest, Wisconsin, into Minnesota for December. Wherever you see white, by the way, that indicates near average temperatures. Let's go over here now to the forecast for January 2024, and we see much of the United States with this white shading. So January 2024, this would be indicative of near normal or near average temperatures in January for whatever location you live at. And then warmer than normal temperatures up and across the southeastern and eastern Canada. And then the forecast from the NMME for February 2024, temperature anomaly forecast showing near normal temperatures along the East Coast, and the warmest to warmer than normal readings across the Pacific Northwest for February. So for the Mid-Atlantic specifically, slightly above normal December, a near normal temperature regime in January and February. The NMME precip anomaly forecast, December here on the left. Wow. Are you getting the same theme here from all the models that we've looked at so far? CanSIPS as well as ECMWF 5 and now the NMME. Same areas expected to have above normal precip from Louisiana, Florida, up the coast to the Mid-Atlantic and to New England in December. So we're getting pretty good confidence with these models kind of aligning themselves that it's looking like it's going to be a wet start to the meteorological winter in December of 2023 along the East Coast. Drier than normal conditions initially out here over the West Coast, including you in California in December. By the time we get to January, we're starting to see a few more pockets of above normal precip for you in the San Francisco Bay Area, for example. Look how the dry area expands across the Pacific Northwest in January of 2024. Drier than normal also across the Midwest, Illinois, Indiana, Lower Michigan, Ohio. And look at the above normal area still in that same zone. generally from the Gulf Coast, southeastern Texas, right along Interstate 10, over to Jacksonville, down to Orlando, and then up the coast, southern Georgia, into the Carolinas and Virginia, and then right along the coastal sections of New England. Not too far inland, but kind of like right along the coast. And then over here on the far right is a precip forecast, anomaly forecast for February 2024. Look how much wetter now we have conditions in California by February of 2024. And then look how much drier things are across the Ohio Valley by February 2024. And then we got this sharp precipitation gradient from above normal along the southeastern coast to below normal Ohio Valley. So there's going to be a fair share of storms. The main storm track is going to be more to the south this upcoming winter season in accordance with El Nino, and then up off the southeast coast, it looks like. Last model I'll talk about from the early September issue is the C3S. C3S, it's a multi-model forecast system. It includes forecasting inputs from the ECMWF, the UK Met Office, the Meteor France model, the German Weather Service, the DWD model, U.S. National Weather Service's NSEP, Japanese Meteorological Agency, and Canada's Environment and Climate Change model, ECCC. All right, so this C3S includes quite a bit of model output from all these different agencies. And it produces 1 or 3 month outlooks. You basically pick your preference for the graphics, covering probability for specific 2-meter temperature anomalies, precip anomalies, 500 millibar height anomalies, shows mean sea level pressure anomalies, 10-meter wind speed anomalies, and the sea surface temperature configuration for the months you want to look at. So let's take a look at the C3S 500 millibar height anomaly forecast, December over here on the left. I apologize for this because I think next month what I'll do is I'll keep the same North American projection. For the C3S, I went with the global projection. But in general, you can kind of get a look to see what's going on in the United States here. For the month of December, this is, again, the 500 millibar height anomaly forecast. The highest, higher than normal height anomalies, the highest heights are going to be located across southeastern Canada. Okay. And then you've got slightly above normal heights across the northern plains to the east coast. By the time we get to the January 2024 forecast from the C3S, 500 millibar height anomaly, now we're starting to see this blue shading across the southern U.S. Noticing that? From Southern California to eastern Texas. So below normal heights are expected in those locations, and then we've got near normal heights across the majority of the United States. There will be some above normal heights, slightly above normal heights forecast for the northern plains. The highest heights are located over Canada. By the time we get to February 2024, the C3S 500 millibar height anomaly forecast here on the right, now we have a more defined band of blue coloring here, which gives us a higher probability of below normal heights from Southern California right along the Gulf Coast and just off the mid-Atlantic. And there's a higher probability of above normal heights across Canada by February 2024. Let's look at the temperature anomaly forecast from the C3S. December here on the left, showing slightly above normal temperatures in this lighter yellow coloring for the United States. The highest, basically the warmest normal temperature anomaly is going to be from Hudson Bay, working our way into eastern Canada again. They're all hitting on the same general upper air pattern here, as well as temperature anomaly configuration. Over here in the middle is the January 2024 temperature anomaly forecast in degrees Celsius, showing now along the east coast in the southern U.S., the southeast, Texas, right to Pennsylvania, we see near normal probability, or probability for near normal temperatures, the white coloring. And then over here on the far right is the February 2024 temperature anomaly forecast from the C3S, showing a stretch from Southern California right along the Gulf Coast to the Mid-Atlantic, white shading indicating near normal temperatures probabilities. Let's take a look at the precip anomaly forecast, December here on the left. Same things are happening here, okay? Above normal light green shading from East Texas to the Mid-Atlantic up to New England in December. Over here in the middle, January 2024, this precip anomaly forecast, this model is forecasting for well above normal or higher than normal probabilities of above normal precip across Florida, right up into the Carolinas. And then over here on the far right is the February 2024 forecast, showing higher probability of Southern California right along the Gulf Coast into Florida and just offshore the Mid-Atlantic. Higher than normal probability for above normal precip. Overall, all 3 months, December, January, and February, I summarize it here with the bullet at the bottom. Wetter than normal conditions are prevalent or expected, according to the C3S, from Florida to the Mid-Atlantic for the winter months. Here is a look at some of the model data for the Niño 3.4 water temperature anomaly forecasts. This is the NMME. It shows you the different coloring. So basically we're sitting right in this area right now in September. These are the different color lines represent these respective models. So for example, the orange line here would represent the CFSV2 model. The red line indicates the Gem 5 NEMO model. The light green coloring indicates the GFDL SPEAR forecast, and so on. So two of the stronger models for stronger El Nino conditions in that 3.4 region, or the most anomalously above normal water temps, include the NCAR CCSM4, and then also the GFDL SPEAR model. That is like the most robust out of all the climate models here for the strength of the El Nino. We're talking about a nearly 2 degrees Celsius temperature anomaly above normal in that Niño 3.4 region, according to the GFDL SPEAR, this light green line here. Majority of the models, now if you look at the black dashed line here, that represents the ensemble, or that represents the mean or the average between all these various models. And so according to the NMME, the ensemble, or the average of the ensemble, is generally located right around 1.5 C before coming back down. We look at the ECMWF forecast. This was issued on the 1st of September 2023 for Niño 3.4 sea surface temperature anomaly plume. This has got a fairly strong El Nino going all the way up above 2 degrees Celsius by the time we get into November, December time period, before things start coming back down. And then over here on the far right, I'm showing the CFSV2 forecast. This is actually from today, from the 11th of September. We're sitting generally in this area now in September, about 1.2 degrees Celsius above normal in the Niño 3.4 region. And that's going, the forecast of the CFSV2 has it peaking at about just under 2 Celsius as we get towards late November, early December. And then it starts weakening a little bit after that. So January and February, it comes back down. So overall summary of all these various models, the European, the ECMWF in the middle here, this 3.4 SST anomaly forecast, it's the warmest of these models. El Nino generally tends to peak in strength, according to these models, between October and December, somewhere in there. And then we start seeing those waters in that Niño 3.4 region cool off a little bit. So we expect weakening of El Nino, or potential dropping from a strong category into the moderate El Nino territory in January and February. CFSV2, by the way, that forecast ensemble, meaning this black dash line, this is the weakest, or the least strong model of all of them. So in summary, the long-range models are indicating a pattern in line with a more typical El Nino winter. What do I mean by that? Let's go to bullet 2. More suppressed southern U.S. storm track with below normal temperatures associated in the south with that increased area cloudiness and storminess. Meanwhile, you'll see warmer than normal temps that are forecast across eastern Canada and over the North Atlantic. That, to me, what I'm looking at so far, many of these longer range models, it's indicative of a potential negative NAO pattern, North Atlantic oscillation pattern. We get a higher upper level block over the top, and that generally promotes cooler than normal temperatures over the mid latitudes, specifically in the United States, the eastern U.S. Pacific. A negative NAO. Now, I talked about this in a couple of videos ago on the Spot on Weather YouTube channel, but when you combine a negative NAO plus El Nino, the results are below normal temps. We look at the mid-Atlantic for sure. So that phase, whether it's negative or positive, the NAO is going to be a huge factor in what happens this upcoming winter season. Now, we are expecting, according to these models we just looked at, we're expecting the temperatures to be slightly above normal in December, so more of a milder start to the winter. And then we see a greater probability. Now, that's the big thing here. Right now, we are still relatively far out in time. When we look at these models, we look at the probability for certain occurrences to happen. And right now, according to these models, the issuance here in early September, Milder start to the winter in December, then a greater probability for below normal temps in January and February across specifically the southeastern and mid-Atlantic U.S. And then long-range models are an excellent agreement. Now, this is really in great agreement, all these models, as far as where those wetter than normal conditions are going to set up for December, January, and February. And right now, the bullseye for the heaviest precip looks to set up from the southern U.S. to the mid-Atlantic. Now, the further north you go along the East Coast, specifically north of Virginia, the lower the probability for above normal precip. I mean, it's still there. There's increased probability for above normal precip. Let's say from Pennsylvania northeastward along the major northeastern cities, New York, Boston. Okay, but it does go down a little bit the probability for above normal precip dropping off towards New England. The further north you go. So this is in general what we're expecting as of right now based on these models. In tonight's video, as a summary, we took a look at we started with a look at the CanSIPS model. We looked at the 500 millibar height anomaly forecast for December, January, February, then temp anomaly forecast, and then the precip anomaly forecast from CanSIPS. We then looked at the European CS5 forecast, 500 millibar height anomalies. This is the most robust out of all the models we looked at with a bullseye over the mid-Atlantic for both January and February. And this actually to me would make sense based on the fact that we're looking at a fairly strong El Nino still in December and then tapering down to moderate territory. I did a video on El Nino types, whether they're weak, moderate, strong, or super, or very strong El Nino events. And the research, when I look back at 9 moderate El Nino winters, 6 of those 9 winters had below normal temperatures across the mid-Atlantic. So I'm really, really interested to see where this El Nino is going to peak out over the upcoming winter, and it's going to have a huge role in determining the strength of the El Nino, the ultimate outcome of what we see with the weather. So really robust here with the CS5 forecast of where that storm zone might be. And then we looked at the temperature anomaly forecast for the CS5. Okay. We looked at the precip anomaly forecast, very similar to CanSIPS. And then NMME, North American Multi-Model Ensemble. Let's take a look at the early September issuance here, the forecast for the winter. Not as cool as far as the southeastern U.S. and mid-Atlantic in January and February as, let's say, this model, the European CS5, has a colder look for the southeastern U.S., the mid-Atlantic, for January and February as compared to this NMME, which has just near average temperatures. Okay. Here is the precip anomaly forecast for December, January, and February. Again, above normal in those same locations. Great agreement amongst all these models as far as the precip anomalies. And then the C3S, generally showing, now the C3S is interesting. It's we look at the NMME, right? And we look at the temperature anomaly forecast in particular. Near average across southeast and mid-Atlantic in January and February, according to this model, NMME. But then we look at the C3S, and it's pretty similar. Temperature anomaly forecast, pretty similar. So these are a pretty good agreement, C3S as well as the NMME, as far as the temperature anomaly forecast, near average winter temps for the southeastern U.S. and the mid-Atlantic. And then here is a look at the precip anomalies. Again, the same areas of the U.S. forecasted to have above normal precip. More up and down the East Coast in December, so a slightly warmer than normal and wetter than normal December starts the winter for the Southeast and Mid-Atlantic. And then we go to a changeover again in January and February, where we still have that wetter than normal conditions fairly close by, in addition to near average winter temps to potentially slightly below normal temps. So that wraps things up tonight. I hope you enjoyed this video. I plan to do this at the beginning of every month. I think this is going to be very beneficial to see. I'm curious to see which of these models actually is going to perform the best. And, I also look, when you look at consistency in the models, that's what you're looking for as far as confidence levels. So the more these agree, the higher the probability basically of it occurring, the higher the confidence level in the longer range forecast. that these are all fairly close in agreement as far as the temperature anomalies, the height anomalies, the precip anomalies. All those are generally in agreement right now. So that's pretty impressive, pretty remarkable right now. But we'll see what happens in early October. We'll see if things change in any of these particular models for the winter forecast. Obviously, they're basing their forecast heavily on the El Nino conditions. Right, that wraps it up tonight. I hope everybody has a great evening. Until next time, take care and God bless everyone.